Hello guys, in today's class, we are going to take us through a concept called algorithm. What do we mean by algorithm? Most of us are familiar with the word algorithm, but we don't know what algorithm simply means. Algorithm is a step-by-step set of instructions designed to perform specific task or achieve an objective. These are structured sets of instructions which is designed to perform specific task or desired objective. That is algorithm in its simplest term. So, what are the stages involved in algorithm? The first stage involved in algorithm is problem definition or identification. We need to understand what the problem means. We need to understand the problem clearly. Yes. What are we trying to solve using algorithm? You have to understand the problem. Example, I want to sort a list of student names in alphabetical order. That is a problem. Then we are using algorithm to solve that. Another step involved is data collection and identification. That is, we have to get some data that we are going to manipulate or work on using algorithm. Yes, that is, we are specifying some set of inputs and data used that will be used in our algorithm process. Data collection determines the input required to solve the problem. Another step is processing design. This deals with our logic and steps involved in algorithm. Yes, the processing design aspect is the aspect which deals with which deals with the steps involved in our algorithm. So this is the actual step-by-step instructions to solve the problem. Another step in algorithm is output. Yes, an algorithm will surely have an output. Output is simply what the algorithm returns. That is as simple as that. Then the last part of algorithm is termination. This is the stopping or end point. That is we are stopping the process of solving the problem. We want to terminate and end the process. That is what terminations means. So now let's move on. Now I want to talk about real life applications of algorithm. Applications of algorithm. Our algorithm is applied in our day-to-day lives, such as banking and finance, problem solving, software development, business, and so on and so forth. So now let's take a look at these two examples. We want to create an ATM cash withdrawal system using algorithm, and we also want to talk about face unlock system using algorithms. Now let's move on. ATM cash withdrawal algorithm. The reason why I choose this is because I want this topic, I want to explain more about it using real life applications. It's very easy for me to choose other parts, such as how to get how to decide if maybe how to decide maybe a number is an even number or odd number, or how to how to print number several times. All those ones, they are applicable in mathematics. But I decided to choose a real life applications of algorithm. So now we want to create an ATM cash withdrawal algorithm. The first part is start. That's the first process. We are creating algorithm for ATM cash withdrawal. Then the second process, insert ATM card. Yes, you are going to insert your ATM card if you want to make use of the ATM cash withdrawal. Then the third one is to enter PIN. Yes, enter PIN. After the PIN is entered, then then the ATM is going to check if PIN is correct or not. This is where the decision making comes in. Yes, this is where the logic of our algorithm comes in. Either to check if a PIN is correct or not. If a PIN is correct, show transactions option, that is, show other transactions option. If the PIN is not correct, show error and allow the user to retry. That is that, as simple as that. Then after that, select withdrawal amount. That is, if the PIN is correct, show transaction options, then select withdrawal amounts. After selecting the withdrawal amount, you also go to other logic of this algorithm, which is check if account balance is sufficient or not. If the account balance is sufficient, deduct amount and dispense cash. If not sufficient, shows insufficient balance. That's also another logic of this algorithm, that is to check if account balance is sufficient or not. If it is sufficient, dispense cash. If it is not sufficient, show error message. That is, show error message that insufficient balance. Then, after dispensing the cash, the next step is to print receipts. After printing the receipts, the next step is to eject the card and end the algorithm. That is that on ATM cash withdrawal algorithm. As simple as that. So that is to tell you that algorithm is a step-by-step set of instructions or process used to solve problems. It is mostly applied in problem solving. That's why if you want to be a problem solver, or you want to be a software developer, or you want to be an engineer, you have to get yourself familiar with algorithm. It's a very, very important concept in problem solving. It will increase your problem solving skills. So now let's move on to the second part, which is face unlock system. Now, you want to apply algorithm in face unlock system. Most of our mobile phones, smartphones use face unlock system. This is the algorithm behind it. The first process is to start. The second process, user face the camera. The third process, the camera will detect a face. The fourth process, the device will compare face with stored face data. If the face match, unlock the device, that is our smartphone, which unlock the smartphone. If the face does not match, try again or ask for PIN. And the last process is to end. That is algorithm for face unlock system. That is algorithm for face unlock system. It is as simple as that. So now let's move on. What makes a good algorithm? What are the properties or characteristics which makes a good algorithm? The first one is clarity. That is, each step must be clear and unambiguous. Yes, an algorithm must be clear. The second one is finiteness. An algorithm must have finite number of steps and must eventually stop. Yes, the algorithm step must be straightforward. It must have finite number of steps and must eventually stop. Yes, you have to end your algorithm. The example which we stated earlier, ATM cash withdrawal and face unlocking system, we eventually stop the algorithm. The third one is effectiveness. It should be simple enough to be executed. An algorithm should be simple and straightforward. The last one is the input and output. Algorithm takes input, process them, and return outputs. So now, algorithm is a very, very important skill. A problem solver, a programmer, a software developer, an engineer should be familiar with. You have to get yourself familiar with algorithm skills because it's very, very important and it makes works easier. Yes, you will not be guessing that, oh, what do I supposed to do here? What do I supposed to do here? Algorithm will make your critical thinking very fast and your problem solving skills very fast. That is the essence of algorithm. So in the next lesson, we are going to talk about another aspect of algorithm called flow chart. Yes, this is when you're using algorithm is to specify the step-by-step instructions used to solve a problem in written form. But flowchart is going to be in visual form. So join me in the next lesson whereby we talk much on flowchart. So I think that is that on algorithm. Thank you very much.